Hello everyone. Today I'm going to talk about the derivatives. As we mentioned before, any line equations can be written as slope-intercept form, which is y equals mx plus b. Here we have 2 points x1, y1, x2, y2, and x2 equals x1 plus delta x. So y1 is the function value x1 and y2 is the function value at x1 plus delta x. The line slope m equals y2 minus y1 divided by x2 minus x1 equals the function value at x1 plus delta x minus function value at x1 divided by delta x. So as you can see, with the delta x is infinitesimally close to 0, which means x2 is infinitesimally close to x1, then the line slope becomes the slope at the specific point x1 with the delta x approaches to 0. So we introduce the derivative concept. At any point x, the derivative y prime equals delta y divided by delta x. Here, the y prime and dy divided by dx are the notations of derivative. Essentially, they are the same. So they are equals limit the function value at x plus delta x minus function value at x divided by delta x with delta x approaches to 0 equals limit the function value at x plus h minus function value at x divided by h with h approaches to 0. Here I use h to replace delta x. In fact, h and delta x, they are the same. They are just variable symbol. You can use any symbol as you like, as long as this symbol approaches to 0. So as you can see, the derivative at a specific point equals the line slope, also equals the tangent RF. Here the RF is the angle between the line and the x-axis. In fact, this formula can be used in any function. However, in that case, the line is referred as a tangent line at that specific point. Now, let me give you an example to calculate the derivatives based on the definition. For example, if we want to calculate the derivative at the point x equals 5 for the function x cubic. So based on the definition, the derivative at the point x equals limit the function value at x plus h minus function value at x divided by h with h approaches to 0. Here we want to calculate the derivative at the point x equals 5. So we use 5 to replace x. Then we can get the function value at 5 plus h by replacing the function variable x. So we can get the function value at 5 plus h, which is 5 plus h cubic minus function value at 5, so which is 5 cubic. Now we want to expand numerator. Then we have to use the formula a cubic minus b cubic equals parenthesis a minus b parenthesis times parenthesis a square plus ab plus b square parenthesis. So we get the denominator as 5 plus h minus 5 times parentheses 5 plus h squared plus parentheses 5 plus h parentheses times 5 plus 5 squared. After some simplification, we can get the limit 5 plus h squared plus 5 plus h times 5 plus 5 squared with h approaches to 0. Now, as you can see, the function is continuous at h equals 0. So the limit at this point equals the function value at h equals 0. So we can use 0 to replace h in the function to get the function limit, which is 75. Alternatively, at first we can get the derivative expression, then we can plug x equals 5 into the derivative expression to get the derivative at the specific point. So based on the definition, derivative equals limit function value at x plus h minus function value at x divided by h with h approaches to 0. The function value at x plus h can be obtained by treat x plus h as a single variable and put it into the function to get the function value at x plus h, which is x plus h cubic minus function value at x, which is x cubic divided by h with h approaches to 0. Then we use the same way to expand denominator, so we get x plus h minus x times parenthesis x plus h square plus x plus h times x plus x square. After simplification, we can get the function limit x plus h square plus x plus h times x plus x square with h approaches to 0. As you can see, the function is continuous at h equals 0, so the limit with h approaches to 0 equals the function value at h equals 0. Then we just plug in h equals 0 into this function to get the function limit, which is 3 times x squared. So this is the general derivative expression for the function x cubic. In order to get the derivative at a specific point, such as x equals 5, then we can just plug in x value into this derivative expression to get the derivative value at that point. Here, we want to get the derivative at x equals 5, so we just plug in x equals 5 into the function to get the derivative 75. So as you can see, you get the same value. This is all for today. Thank you for watching.